In this video, I'll explain interfacing of a DC motor with the microcontroller. For this example, we have selected Atmega 16, but the concept can also be applied to other micro. We also need one motor driver IC, so it provides the current required to drive the motor. So it has four inputs: 1A, 2A, 4A, and 3A. And these are the outputs: 1Y, 2Y, 3Y, and 4Y. For a single motor, we need two inputs and two outputs, two input lines and two output lines. Okay, so we are going to use 1A and 2A, and 1Y and 2Y are the outputs corresponding to 1A and 2A. Okay. So 1Y and 2Y are connected to the DC motor, and 1A and 2A are connected to the microcontroller, to GPIO ports. The enable must be high so that we can also connect to the one of the GPIO port of the microcontroller. Now it has two VCCs, VCC1 and VCC2. So VCC1 is the power supply required to drive the IC, which is 5 volt, and VCC2 depends on the motor rating. So it is the power, or it is the voltage required to drive the motor. The pin number 9 is the enable signal for this channel, for this combination 3 and 4A and 3Y and 4Y. And pin number 4, 5, 12, 13 are heat sink and ground. So the IC can provide 600 milliampere output current per driver, wide range of power supply from 4.5 volt to 36 volt. This is the interfacing circuit diagram. So the inputs IN1 and IN2. So these are 1A and the 2A, which are connected to the PB1 and PB2, and enable is connected to the PB0. Then we have VCC1 and VCC2, both are connected to the plus 5 volt supply. Then we have out1 and output corresponding to the 1Y and 2Y, which are connected to the DC motor. This is the basic functionalities. The enable must be 1 to run the motor. So for this combination, motor will run. For the second one, the motor will run, but the direction of movement will be opposite. So the motor will run in the opposite direction. In this combination, the motor will be stopped, and this is the combination to stop the motor. When the enable is 0, so irrespective of IN1 and IN2, the motor will be stopped. Now let's listen the programming part. So first we have to do basic configuration. So first we have to configure the PB0, PB1 and PB2 in the output mode. So for that we have direction control register. So we have to write 111 in the corresponding bit position of the DDRB, because this is corresponding to PB0, this one is for PB1, and this one is for PB2. Okay. Next we have to write different functions for different motor operations. So let's understand the first run, to run the motor. So to run the motor, we have to write data to these pins. So for that we have port data register. So in the port data register, we have to write 1, and we have to make this 0, and this is corresponding to IN1, and this is corresponding to IN2, and this is enable signal. Yeah, so we have to write this syntax: port B or is equal to 0x03. Okay, now this syntax will make IN1 is equal to 1 and enable equal to 1, but we also have to make IN2 equal to 0. So for that we have to write the statement port B and is equal to not 1 left shifted 2. So basically what we are doing, first we are making 1 1 at these bit positions, then we are doing AND operation with this number. So we don't know these bits, this could be 0 or 1, and but we want to make this 0. So for that we'll do AND operation with this number 11111011. So this can be written as 1 left shifted 2, or we can also write this number as f, and this is 11, or we can write b in the hex, so fb. So either we can write port b and is equal to not 1 left shifted by 2, or port b and is equal to 0x fb. Next we have to change the direction. We have to make in to 1 and I1 0. So in 2 is equal to 1, in 0, and this must be 1. So we have to make this is 1, this bit 1, and this bit 1, and we also have to make this 0. So to make this 0, either we can write port b and is equal to 1, not 1 left shifted by 1. So after making these two bits 1, so these bits could be 0 or 1, and then we have to make AND operation with this number 1111011. So this is equivalent to not 1 left shifted by 1, or this number is equivalent to f, and it's 13, so it's d. So we can write fd. Okay. Now to stop the motor we have to write this. Let's say enable is 1, so we can make this 0, this bit 0 to stop the motor. Okay. Next. Okay, so we can do AND operation with this number 111110001. So this is f and this is 9. So we can do AND operation with this number f9, or we can make these two bits 1 1. Okay, so we can make 1 1 also. So in that case we have to do OR operation with this number 0x07. So this is the combination corresponding to stop the motor.